I'm giving you a simple question based on the dependent source. Draw the diagram. You have to simply apply KVL. Okay. Now tell me, how many meshes are there? Two meshes are there. Two meshes means two variable. Here one of the variable is I1 and another variable is I2. So I told you for two mesh we need two variable, and for two variable we need two equation. But there is one dependent source, that is an extra. Okay. So for dependent source we have to make one equation extra. So in total we need to make how many equation? Three equation. If suppose in the question there are two dependent source, so we need to make two equation extra. Okay, understood? So in total we have to make three equation for solving, because there are basically three variable. One variable is I1, another variable is I2, and the third variable which is due to the dependent source, that is Vx. Now tell me the first equation. Apply KVL and tell me the first equation. What would be the first equation?
12 minus 4vi minus
4I1, because here in this current is flowing in I1. Okay, then
minus 9 Vx
is equal to 0, because it is a voltage source, right? It will behave as a voltage source, and the value of voltage source is Vx. So I'll write down the complete value of voltage. Okay, now tell me the next equation.
Okay, so it will be we can start with 9Vx minus 6I2.
Okay, tell me one thing. Can we apply KVL where your current source is present? Because according to the Kirchhoff, he stated that algebraic sum of all the EMF plus algebraic sum of all the voltage drop is equal to 0. He didn't talk about the current source. So wherever the current source is present, we can't apply KVL from that. Okay. So if the current source is present, we have to make the direct equation. Like you can see, I2 is moving from up to down, and 8 ampere is also moving in the up to down. So both are in the same direction. So we can directly write down I2 is equal to 8. Okay. Now tell me the third equation which is due to the dependent source.
This will be I1 minus I2.
No, see how we can make the third equation which is due to the dependent source. We have to see that which source it is, like which it depends on which. Like I'm giving you one example. You are a student, you are depending on your mom, okay, and you on your dad, right? So for food we can consider you are depending on your mom, right? For money we can consider you are depending on your dad, right? So whenever you want food, you are searching where your mom where was, and whenever you need money, you are searching for your dad. Okay, so let us consider mom is your current, it's a female, okay, and dad is your voltage, it's a male. Clear? So now I'm like creating logic for this question. It is depending on voltage, right? It is depending on voltage means it is depending on father, means you are depending on your father. So you will search for your father where your father is present, right? So your father is present here. Okay, so wherever your father is present, you have to make KVL equation. If you have to make third equation from that. Like again back to this concept, if you are depending on your father means voltage, you will always make the equation by using Ohm's law, that is V is equal to IR. If you are depending on mom means the current, if you are depending on mom your means current, it means that you will calculate that equation directly from the current. Like suppose if your mom is in the middle wall, so in the middle wall, as you know, in the middle branch there is a flow of two current, right? Remember now concept that I1 and I2, like suppose this is 8 ampere, so I1 and 8 ampere are flowing in the same direction, so I1 would be positive, I2 and 8 ampere are moving in the opposite direction, so I2 would be negative. That is it. And if your mom is present in the corner wall, okay, then we can directly write down I2 is equal to 8 ampere. That depends on the question. If it is in the middle wall, there is a flow of 2 current. If it is in the corner branch, then there is a flow of single current. Okay, for mom, you can calculate directly equation from the current source, but for dad you have to use always Ohm's law. Okay, now see, you are depending on your dad, so we have to make equation from the Ohm's law. According to Ohm's law, V is equal to I multiplied by R, right? V is how much here? Vx, so we can write down Vx. And how much is the current flowing in this particular area? That is I1, so we can write down I1. And how much is the resistance for that particular area? That is 4 ohm. So we got it, our third equation. Clear? Now see, we are having three variable I1, I2 and I3. Three variables, three equation, we can solve it and then we'll get the